All right, so we're quickly going to learn one really important law that you're going to use quite a bit moving forward, and then a couple less common laws, but laws that we definitely want to put into words so that we can articulate reasons behind some claims that we might make. So I'm going to ask you here to answer this first question. Given the premises the butler is the killer, or the chef is the killer, and also the butler is not the killer, what can you conclude? Go ahead and read these two statements, which are both true statements, and tell me what you could conclude from that in words. So obviously, if you're given a statement where two things are stated in a disjunction, such as the butler is the killer or the chef is the killer, you now know that either they're both the killer, because disjunctions can be true if both things are true, or one is true and one is false, so one will be the killer and one would not be. If you're told that the butler is not the killer, that rules out the butler being the killer, meaning if this is a true statement, it could only be true if the chef is the killer. That's the only thing that makes any sense at all. And we started talking about this last week. We learned about this law, but we didn't put it into one specific, concise expression yet. So that's what we're about to do here. Now, if we were to use symbolic representation, this would make even more sense. So let's say the butler is the killer is B, and the chef is the killer is C, and we're told that the butler is the killer or the chef is the killer. But then we're told that the butler is not the killer, which means that not B must be true. Well, from this information, I could obviously conclude then that C must be true. And that's because I've been given a disjunction that's true, and then I was told that not B was true, meaning B is false, so C is true. It's the only way for that to be possible. This is the law of disjunctive inference. If you're given a disjunction that's true, and then you're told that one element of that disjunction is false, then the other element must be true. And that's the big law, the law that we're actually going to use moving forward. All right, we are going to prove this theory using a truth table here. So we're just going to show that this is obviously true no matter what. And I'll just create a truth table that's going to have to include P. It'll include Q. We do have a not P, and then the disjunction P or Q. So let's just go ahead and fill in this truth table. So from what we know about disjunctions, they are true as long as one of the two elements is true. If they're both false, though, then the disjunction is false. So just to prove that the law of disjunctive inference works, we're obviously assuming that the disjunction is true. So we're not talking about that line there, because that's the only case where the disjunction is false. And then we're assuming that not P is a true statement. So that means we're not talking about either of these two lines, because not P is false in both of those cases. So we're really just paying attention to that third line. And it turns out that if your disjunction is true and not P is true, then what has to be true about Q? It's got to be true. And this is the idea behind making this claim. But now we don't have to explain it out in words. We can just refer to the law of disjunctive inference in our reasons for any proof. All right. Now we're going to practice using this law of disjunctive inference. So I'm just going to pause here and give you a minute to come to a conclusion from each of these. All right, so for A, if you are told that A or not B is true, and then you're told that not A is true, what could you conclude? Well, using the law of disjunctive inference, we'd be able to say, therefore, not B must be true. Letter B says not C or not D is true, but C is true. So, using the law of disjunctive inference, what could we conclude? Well, if C is true, then not C is false, so then not D must be true. And now example C. If H or G is a true statement, and then G is a true statement, what can we conclude? So this is actually sort of a trick question, because you can't conclude anything. And here's why. If we go back to our truth table for disjunctions, our disjunction is true in all of these cases, so let's only look at those. We won't pay attention to that bottom row. And we're looking at our second element being true. So Q is true here and here. What does that tell us about P or H? Well, it could be true or it could be false. We don't know anything. So if you are told that a disjunction is true, you need to be told that one of these elements is false. If you're not, then you can't conclude anything. If all I know is that G is true, well, clearly then H could be true or it could be false. Either way, this disjunction can be true. So I need to be told that H is false or G is false. All right, so now we're actually going to see this in a proof. We're going to use the law of disjunctive inference to prove the following conclusion. So given if Q then R and P or Q and not P, we need to prove R. So we'll make our two columns and set up our statements and our reasons. Okay. Eventually we want to prove that R is true, and we're going to give a reason for that, but we've got to work our way there, so let's think about this systematically. It would be great if I could just claim that R is true using the law of detachment, but that would only work if Q were true, because then I could use the law of detachment. Do I know that Q is true? Well, I could try to get myself to that point using these other two pieces of information. So if I know that I have a disjunction that's true, and one component of that disjunction is not true, then the other component must be true. So I can say that Q is a true statement because of the law of disjunctive inference. And I'm using lines 2 and 3. Now I can claim that R is a true statement. So don't need that down there. I am going to claim that R is true at this point. Because I can use the law of detachment here, since I have a conditional statement and the hypothesis of that conditional statement is determined to be true. So this is the law of detachment. And now we've proven what we needed to prove. So we are going to start seeing the law of disjunctive inference go hand in hand with some of the other laws that we've proven. Before we get to any practice that I'm going to have you do on your own, I do have 3 other laws that I want to get down in writing here because we may use them tomorrow or moving forward with any logical situation. Our first law is called the law of simplification. And what this law says is that if you have a conjunction like P and Q that's determined to be true, that tells you that P has to be true. It also tells you that Q has to be true, right? Because conjunctions are only true if both of these elements are true. So if you're given a conjunction, then you can conclude that each element individually must be true. So that's the law of simplification. Now, the law of conjunction goes the other direction. And what this says is if you know that P is true and Q is true, if you want to, you can conclude that therefore the conjunction P and Q must be true. And that could be useful in some situations moving forward. Now we also have this other law called the law of disjunctive addition. And this one deals with disjunctions and says if you're told that something is true, if you're given the premise P, then you can conclude that the disjunction of P and anything else, for example R, is a true disjunction. Because remember, disjunctions are true as long as one of the two elements is a true statement. So I could say anything there. I could say R or T or not Q or L, whatever I want, and that would be a true statement. So those are the other 3 laws that go with this lesson here. We will not use them as often as we'll use the law of disjunctive inference, but they are laws that you can use. So let's just do a couple practice problems. All right, so taking a look at this first example, if you are given the premises not S or not R, and S, what can you conclude? I'll pause and let you answer. Well, we're given a disjunction, and we're told that one element of that disjunction is false. Therefore, not R must be a true statement. And now this next one says James or Kyle finished the race. So let's say that P is James finished the race and Kyle finished the race is Q. So we're told that P or Q is true, and then we're told that James finished the race, so P is true. I'll pause and let you come to a conclusion here. Make sure you write your conclusion out in words. All right, well, what can we conclude here? We're given a disjunction. We're told that one element of that disjunction is true. That doesn't help us at all. There's no conclusion we can draw here. We need one of those elements to be false. So no conclusion in this case. All right, now the last thing we're going to do is we're going to go ahead and do one proof together. And what we're going to do is I am going to write a statement, and then you're going to tell me the reason. So write a formal proof to show that the following conclusion follows from the given premises. All right, so we'll go ahead and start by setting this up. We got our two columns. All right, eventually I want to say A is true, and I want a reason for that. But I can't get there yet. I don't even have an A anywhere in this statement. So the next thing I'm going to do is I'm going to use that first statement, and I'm going to claim that not C, if not C, then not A and B is true. And I'm going to pause and let you tell me why that is. Give me the reason. Okay. Now the reason for that is because of the law of contrapositive. Which says that if P then Q, then I can claim that not Q, if not Q, then not P must be true, which is what we're doing here. We just have sort of a more complicated P, right? All right, now from there, I can claim that not A and B must be a true statement. Again, I'm going to ask you to tell me how I can make that claim. Give me my reason. All right, and that is because of the law of detachment. Because I have a conditional statement, and the hypothesis of that conditional statement is true, I can claim that the conclusion must be true. And 6, now what I'm going to claim is that A or not B must be a true statement. Go ahead and give me a reason for why that is. All right. Now the reason that I can give here is because of De Morgan's laws. Which says that if I negate a conjunction, that's the same as a disjunction if I negate each of the two individual elements. And now finally, I can actually claim that A is true. And the reason here is because of the law of disjunctive inference. If I have a disjunction and I'm told that one element of that disjunction is false, then the other element must be true. All right, and that does it. Tomorrow we will do some proofs involving all of our different laws together.